Hello everyone, welcome back to my YouTube channel Physics Unification. In the last video, we discussed some topics from the Units and Measurement chapter. Today, we are going to learn some main topics from that chapter. So, what we are going to discuss? First, errors and its types, accuracy and precision, absolute, relative, and percentage error, significant figures, dimensions, dimensional formula, and dimension equations, application and limitations of dimensional equations. These topics are very important for exams. Okay, let's see what do you mean by error. In every measuring instrument which contains some uncertainty, those uncertainty are termed it as error. In error, there are two main types: systematic error and random error. Then what do you mean by systematic error? Here, that uncertainty is tend to be in one direction, either positive or negative direction. So in systematic error, there are some sources are there. Those sources are very important for exams. Means they will ask mention the sources of systematic errors for 2 marks. So what are they? First one, it is instrumental error. Second one, it is imperfection in experimental technique. Third one, it is personal error. So then what do you mean by random error? Random error means which arises due to the random fluctuations in experimental conditions. Random fluctuations in experimental condition means there is some random or unpredictable fluctuation in some experiment. Those errors are called as random error. So we can see this least count error while doing the experiment. What do you mean by least count error? The smallest value that can be measured by the measuring instrument. That means a very small value we can measured in the experiment. Then what do you mean by accuracy? Closeness of the measured value to the true value of the physical quantity. Next one, it is precision, which tells us to what resolution or limit the quantity is measured. ಯಾವ ರಿಸೊಲ್ಯೂಷನಿಗೆ ನಾವು ಕ್ವಾಂಟಿಟಿನ ಮೆಜರ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ತೀವಲ್ವ, ಅದನ್ನು ನಾವು ಪ್ರಿಸಿಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗೆಯೇ ಟ್ರೂ ವ್ಯಾಲ್ಯೂ ಮತ್ತು ನಾವು ಮೆಜರ್ಡ್ ಮಾಡಿರೋ ವ್ಯಾಲ್ಯೂಗಿರುವ ಕ್ಲೋಸೆಸ್ಟ್ ರಿಲೇಷನ್, ಕ್ಲೋಸೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂನ ನಾವು ಅಕ್ಯುರಸಿ ಅಂತ ಹೇಳ್ತೀವಿ. Next, we can move toward significant figures. Then what do you mean by significant figures? That is the reliable digits plus the first uncertain digit. So how we have to find out significant figures? In NCERT book, they are given that some rules while writing significant figures. In that, first one is all the non-zero digits are significant. You can see here your roll number 1, which shows all the non-zero digits are significant. Means if it contains numbers, we can count it as significant figures, and that one is 3. In second rule, they are given that all the zeros between the two non-zero digits are significant. You can see here which contains two non-zero digits and 1 zero digit is there. Here in this number, significant figure is 1, 2, 3, 4. Third rule is if the number is less than 1, the zeros on the right of decimal point but to the left of the first non-zero digits are not significant. You can see here that one is a rule number. Third example, this one is rule number second example. In rule number 3 example, 0.010 is there. Here 2 zeros are there in between decimal point. Here in this example, we can count significant figure as 1 and 0. That one is 2 significant figures are there. Next rule it is the terminal 0 in a number without a decimal point are not significant. That is, you can see it is in this example, rule number, for example, 12300 centimeter. Means in this example, terminal 0 in a decimal point are not significant. Means we have to count in significant figure it as 1, 2, 3. Means 3 significant figures are there in this example. Next rule it is the terminal 0 in a number with a decimal point are significant. If zeros are there along with decimal point, we can count those zeros in a significant figure. That one is 14.00. In this example, significant figure is 4. Next it is absolute error. It is the magnitude of the difference between the true value of a quantity and its measured value, which is always positive in nature. Why? Which contains magnitude sign. Next, relative error. It is the ratio of the mean absolute error to the mean value of the quantity, which gives the relative error. Then what do you mean by percentage error? If the relative error is expressed in percentage, which gives percentage error. Next topic is dimensions. Then what do you mean by dimension? A dimension of a physical quantity are the powers to which the fundamental units must be raised to obtain the unit of that physical quantity. Means what do you mean by dimensions? Just by substituting the fundamental units, we can obtain the unit of that physical quantity, which gives the dimensions. How we have to write dimensions of some base quantities? See, let's see. Length, we can write it as L. Mass, M. Time, T. Electric current, A. Temperature, K. Amount of substance, it is in mole, and luminous intensity, it is in candela, C, D. Next topic is dimensional formula. An expression in which the derived unit of a physical quantity is expressed in terms of fundamental units. Derived units ಅನ್ನು fundamental units ಆಗಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಅಂತ ಹೇಳ್ತೀವಿ. So next topic it is dimensional equation. This one is very important while writing the units. First one it is velocity. How we have to write dimensional equation for velocity? We know velocity means displacement divided by time taken. Here displacement means there is a change in length. So length can be written it as L1 M0 T0, and time can be written it as M0 L0 T1. Here M0 means we know a to the power of 0 is equals to 1. So M0 means 1. Here M0 also it is equal to 1. L to the power of 1, L to the power of 0 is there. So which gives L to the power of 1. T to the power of 0 in denominator, T to the power of 1 is there. When it is comes to numerator, which gives T to the power of minus 1. So LT minus 1 is the dimensional formula for velocity. In the similar way, acceleration is equals to velocity divided by time taken. So how we have to write velocity? M0 LT minus 1, here it is, and time can be written as M0 L0 T1. M0 means it is 1, that is M0 LT minus 2. So acceleration can be written it as LT minus 2. Next, force. We have to write dimensional equation for force. We know force is equals to mass into acceleration. So is equals to, for mass, how we have to write dimensional formula? Mass means only m. Here m1 is there, l0 is there, t0 is there. For acceleration, we know acceleration dimensional equation is lt minus 2. Just by equating both, we can get m1 l, here 0 is there, here 1 is there, means l1 t, here it is 0, here it is minus 2, means minus 2. So dimensional formula for force is mlt minus 2. Next, we have to write dimensional equation for energy. Energy is equals to force into displacement. Force, you can write dimensional equation as mlt minus 2, and displacement can be written in terms of m0 l1 t0. Here m1 is there, so you will get finally m1 l, 1 here it is, 1 here it is, means l square t minus 2. ml square t minus 2 is the dimensional equation for the energy. Next, area is equals to length square, it is in meter square. We will get dimensional equation as L square. Volume L cube, that one is meter cube. Finally, we will get dimensional equation as L cube. For density, that one is mass divided by volume. Dimensional formula for density is mlt ml minus 3. For work or energy, it is force into displacement. We can express it in terms of unit is joule. So in dimensional formula, ml square t minus 2. Already we derived that one. Momentum or impulse can be written as force into time. In SI unit, Newton meter. In dimensional equation, mlt minus 1. Power is equals to work divided by time. In terms of unit, joule per second or watt. In terms of dimensional equation, ml square t minus 3. In the similar way, we can write dimensional equation for all the terms. Then, how we have to write dimensional equation for torque? We can see here. Torque is equals to force into position vector r. In terms of unit vector or in terms of units, that one is Newton meter. Force is ml t minus 2, and for position vector, that one is displacement, for that one it is L. Finally, we can get dimensional equation for torque as m L square t minus 2. This one is important for exam point of view. Next one, it is surface tension. Surface tension is equals to force divided by 2 into L. In units, Newton per meter. Then how we have to write dimensional equation for surface tension? For force, it is m L t minus 2. For length, it is L. The dimensional equation for surface tension is equals to m L, here 1 means L0 t minus 2. M L0 t minus 2 is the dimensional equation for surface tension. This one is also important for final examination. Next one, it is coefficient of viscosity. Coefficient of viscosity is equals to F into R divided by A into V. Here R is distance between the two layers, A is area of that tube or layer, V is velocity. Just by substituting all the terms, we will get finally dimensional equation for coefficient of m L minus 1 t minus 1. For frequency, it is 1 by t. That one is the dimensional equation. In terms of dimensional equation is t minus 1. Next one is application of dimensional equation. This one is very important for 2 marks in final examination. First one, it is to check the correctness of equation. Whether that equation is correct or not, we have to check. To check that equation, dimensional equation is useful. Second point is to deduce the correct relationship between different physical quantities. Third point, conversion of unit in one system to another system. To convert unit in one system to another system, we can use dimensional equation. Next one topic is limitations of dimensional analysis. Here, for first point is the value of constant cannot be determined with the help of dimensional equations. This dimensional equation or dimensional method is not useful to find the constant value. And second point, this method cannot be used to study relations having trigonometry, logarithmic or exponential functions. Third point is this method is useful only when the relationship is of product form but not sum or differential form. These are the some 3 limitations and applications of dimensional equations. Next one is to check the correctness of the equation. Here we have to check the LHS and RHS part depends on dimensional equation. Let us see LHS equal to final velocity v. How we have to write velocity in terms of dimensional analysis? Velocity can be written as m0 L t minus 1. So RHS, which contains 2 parts, v0 plus at. So v0 in terms of dimensional analysis can be written as m0 L t minus 1 plus acceleration can be written as m0 L1 t minus 2 and time can be written as m0 L0 t1. So here m0 Lt minus 1, which gives the initial velocity v0, plus m0 can be written as m0 as it is, L1 L0 is there, so L1, t minus 2 t1 is there, so it becomes t minus 1. Here LHS equals to RHS, hence the proof. Therefore the equation is dimensionally correct. This one is the first derivation. That one is depends on first application of dimensional analysis to check the correctness of the equation. Second equation is 2x is equals to 2v0 t plus at square. This is similar to that of x is equals to v0 t plus half at square equation. LHS equals to 2x. 2 is constant term, just leave that one. X can be written as m0 L1 t0. That one is L1 only, LHS part. RHS equals to 2v0 t plus at square. v0 is initial velocity, can be written as m0 Lt minus 1 and t can be written as m0 L0 t1 plus a means acceleration can be written as m0 Lt minus 2 and t square can be written as m0 L0 t2. It becomes m0 L1 because L1 is there, here 0 is there, so 1 minus 0 is 1, t minus 1 1, it becomes t0 plus m0 L1 0, that one is L1, t0 it becomes minus 2 plus 2, it becomes t0. So it is equals to L1 plus L1. So and LHS equals to RHS, hence the proof. Second equation, that one is dimensionally correct. Second application of dimensional analysis is to deduce the relationship between different physical quantity. Here we have to relate to physical quantity, depends on dimensional analysis. Before going to that, we should know the meaning of time period. What do you mean by time period? The time taken for one complete oscillation to occur. First one is to deduce the equation for time period of simple pendulum. That means t is equals to 2 pi square root of L by G. This one we have to derive. This derivation is very important for 3 marks for the final examination. Let us see how to derive this equation. The time period of oscillation of a simple pendulum is to be dependent on mass m, length of the string L, and acceleration due to gravity g. That is, time period t is directly proportional to the m to the power of x, L to the power of y, and g to the power of z. Here x, y, z are constant terms, powers. So t is equals to k into m to the power of x, L to the power of y, g to the power of z. K means constant of proportionality. Let us say, now we have to apply dimensional formula on both sides of the equation 1. This equation is equation 1. LHS equals to time period t is equals to m0 L0 t1. Why? Here which only contains time constant, that one is t. It becomes t1. Now RHS equals to k into m to the power of x, L to the power of y, g to the power of z. K is constant term, just leave that one, and m is mass term, it becomes m to the power of x. L is length term, it becomes L to the power of y, and g is acceleration due to gravity, it can be written as Lt minus 2 all to the power of z. Now see, LHS and RHS part, just equate both the sides, then it becomes m0 L0 T1, that one is LHS part, and RHS part can be written as m to the power of x, L to the power of y, Lt minus 2 all to the power of z. Then it becomes x term. Here see, m to the power of 0 is there, here m to the power of x is there. Means powers are constant. Powers are equal to each other, then it becomes x is equals to 0, and L to the power of 0 is there, L to the power of y is there, it becomes, and again Lt minus 2 to the power of z is also there. It can be written as 8. Here this can be written as m to the power of x, L to the power of y, and here also it contains L to the power of z and L to the power of minus 2z. Just by comparing your LHS and RHS part, it becomes x is equals to 0, y plus z equal to 0, and minus 2z equal to 1. Hence z equal to minus y, just by sending y on right hand side, z equal to minus y, and here z equal to minus 1 by 2. Hence y is equals to minus z. So we know value of z equal to minus 1 by 2, hence the value of y equal to 1 by 2, and x value equal to 0, we already got that one, and z equal to minus 1 by 2. Then by substituting all the terms x, y, z in equation 1, we get 1 t is equals to k into m to the power of 0, L to the power of 1 by 2, and z to the power of minus 1 by 2. It becomes t is equals to 2 pi into square root of L by z. Here 2 pi is constant of proportionality k. Next derivation is the centripetal force acting on a particle, that one is depends on mass m, v and r. Means we have to derive centripetal force F should be equal to mv square by r. This one is also very important for 3 marks for the final examination. How we have to derive this one? Let's see. We know force is equals to, means force is directly proportional to the m to the power of x, v to the power of y, and r to the power of z. Means centripetal force is directly proportional to the mass and velocity and radius of the object. So LHS equals to force. We know dimensional formula for force is equals to m1 L1 t minus 2. That one is LHS part. On RHS part, which contains m to the power of x, v to the power of y, and r to the power of z. M can be written as it is m to the power of x. V means velocity. Velocity can be written as Lt minus 1 all to the power of y. R means radius. Radius can be written in terms of dimensional formula. That one is L to the power of z. Then LHS, just by equating LHS and RHS, we can write equation as LHS is m1 L1 t minus 2 is equals to RHS is m to the power of x, L to the power of y plus z. Why? Here L to the power of y is there, and L to the power of z is also there. Then it can be written as L to the power of y plus z. Then t to the power of minus y. Just by equating LHS and RHS part, we get x is equals to 1, x is equals to 1, y plus z is equals to 1, and minus y is equals to minus 2. Then it becomes y is equals to 2, z equal to 1 minus y, that one is 1 minus 2, z is equals to minus 1, x is equals to 1, we already know it. Then centripetal force F can be written as K into m to the power of 1 v square r to the power of minus 1. This becomes finally F is equals to mv square by r. This one is the final expression for centripetal force. These are some important questions based on units and measurements chapter. How they will ask for the final examination, let's see. First, they will ask like this. Check the correctness of equation F is equals to mv square by r using dimensional analysis, where the symbols have their usual meaning. This derivation we already did it. Second, check the correctness of equation v is equals to u plus at square by the method of dimensions. Just by applying dimensional formula on LHS and RHS part, we have to check whether that equation is dimensionally correct or not. Third question it is, gravitational potential energy of a body is found to depend on its mass, acceleration due to gravity, and height of its position. Derive the expression for gravitational potential energy using method of dimensions. Means here we have to derive the expression half mv square, that means energy is equals to mgh. How we have to derive this one? We know energy dimensional formula, just apply it, and we know dimensional formula for mass, gravity, acceleration due to gravity, and height of the particle, that one is L. Just applying all the terms and equate LHS and RHS part, we will get the value of certain quantities, and then just finally we will get the final expression, gravitational potential energy is equals to mgh. These type of questions they will ask for the final examination from this chapter. And simple 1 mark questions like what do you mean by significant figures, or write the dimensional formula for torque, surface tension, force, density, like that. Or one more, what do you mean by accuracy, type of accuracy, what do you mean by error and type of error. Those questions are, they will ask it for 1 marks. For 2 marks, they will ask questions like this. Write the applications of dimensional equations, or write the limitations of dimensional equations, or to check the correctness of the equation, that one is v is equals to ut plus half at square. Sorry, that is x is equals to ut plus half at square. Or one more equation, that is final velocity v is equals to v naught plus at. Those type of questions they will ask it for 2 marks. Okay, fine. Thank you for watching this video. In next video, I will explain about chapter number 3, motion in a straight line. That one is very important for your final examination. And these units and measurements, this is also important for your 3 or 4 marks. Stay tuned. Like, share, subscribe, and press the bell icon. Thank you.